Hello again, everyone. Last time we discussed adding and subtracting fractions. In this video, we'll be discussing multiplying and dividing them. Multiplication is probably the most straightforward option when it comes to fractions. If we have two fractions that are multiplying, like a over c times b over d, we simply multiply the numerators together on top, and then the denominators multiply together on the new bottom. So here we'll get a times b divided by c times d. For example, consider 2 over 3 times 5 over 8. Multiplying across the top will give 2 times 5 on top. Multiplying across the bottom, 3 times 8. Doing the multiplication gives us 10 on top, and 3 times 8 is 24 on the bottom. We always want to check to see if we can simplify. Both of these numbers are even, so we can divide each of them by 2. This will end up giving us 5 over 12, and that's our answer. Let's also consider a case of a fraction multiplied by a whole number, 1/2 times 10. Whole numbers can just be thought of as numbers over 1, so writing this multiplication out with fractions is 1/2 times 10 over 1. And this makes it clear how we want to multiply across the top to get 1 times 10 on top, and 2 times 1 on the bottom is 2. We end up getting 10 divided by 2, which is just 5. While multiplication is relatively simple, it's dividing fractions that usually throws people off. If we have one fraction, a over c, divided by another fraction, b over d, the phrase we use to remember how to do this is keep, change, flip. We keep the first fraction, so a over c. We change the division to multiplication, and we flip the second fraction, or take the reciprocal. So flipping b over d will give us d over b. Keep, change, flip. Let's work an example. Consider 3 over 5 divided by 1 over 5. We keep the first fraction 3 over 5, we change the division to multiplication, and we flip the 1 over 5 to get 5 over 1. Multiplying across, we get 3 times 5 on top and 5 times 1 on the bottom. Before we go ahead and do this multiplication, we can note that we have the same multiplicative factor on the top and the bottom, both this 5 on top and the 5 on the bottom. When this happens, we say we can cancel them out. That is, they divide away. Because 5 over 5 is just going to be 1, so it's just 1 times whatever is left once we cancel them out. In that case, we get just the 3 over 1 left over, which is just going to give us 3. We can do this same process whenever we have fractions in fractions. For example, consider 6 over 2/3. Whenever you see something like this, it'll help if you write the big division bar as a division symbol, giving us 6 divided by 2/3. We can again write the whole number as a fraction over 1, still divided by 2/3. Now doing our keep, change, flip, we get 6 over 1, keeping that fraction, change the division to multiplication, and flip the 2/3 to get 3 over 2. Multiplying across will give 6 times 3 over 2. Again, while we could multiply the top out, we can also realize that since division and multiplication have the same rank, we can do some division first, and this 2 will actually fit nicely into that 6 on top. Doing the division, 6 over 2 will give us 3, which still has to multiply the 3 that was already in the numerator, which will give us 9 for our answer. There's an important distinction to make if we were trying to do this operation on our calculator. Remember, anytime we have a division bar, we want to think of the numerator and denominator inside their own sets of parentheses. So this operation would be input as 6 divided by parentheses 2 divided by 3 in parentheses. If instead you tried to plug in 6 divided by 2 divided by 3, the calculator will read this as 6 divided by 2 divided by 3, which is different from dividing by 2/3. This sequential division will give us 6 divided by 2 is 3, still over 3, which will give 3 over 3 is 1. This is not the answer to the calculation we wanted. Written out in division bar form, it would look something like this. And with that, we've wrapped up fractions. Until next time.